This is question 11, paper 1, from the SQA Specimen Paper for National 5 Mathematics. We're asked to express this difference of two fractions as a single fraction and write it in its simplest form. So let's have a look at these two fractions. We've got 4 over x plus 2, and we have to subtract 3 over x minus 4. I think first of all we should maybe look at a numerical example to give us some idea of how we tackle a question like this. So let's look at a question 4/11 minus 3/5. So the way we would tackle this, 11ths and 5ths are different. We have to create the same number on the denominator of these fractions, down at the bottom of these fractions. And we would do this by balancing the fractions. We're allowed to multiply the top and bottom number of a fraction by the same number. So we'd change them both into 50/5ths, and we'd do that by multiplying top and bottom of the first fraction by 5 and top and bottom of the second fraction by 11. And that then gives us, in this case, 20 50/5ths minus 33 50/5ths. And because they're all 50/5ths, we can now say, well, there's 20 of them minus 33 of them, so there's minus 13 of them. So we get our final answer, minus 13 50/5ths. Crucial stage was this, where we have 55 on the bottom of each of these fractions. So we attempt to do this in this case, x plus 2, x minus 4, they're just behaving like the 11 and 5. Notice we're multiplying the bottom of the first fraction by the bottom of the second fraction here. So let's see if that'll work in this case. Multiplying top and bottom of the first fraction by x minus 4, and subtracting, let's multiply the top and the bottom of the second fraction by x plus 2. Now it doesn't matter which order you multiply top and bottom by. So there's x plus 2 times x minus 4 and x plus 2 times the 3. And we've now reached this stage where the denominators are both the same, and in the numerical case they were both 50/5ths. In this case they're both x plus 2 times x minus 4ths. And how many of these do we have? We've got 4 lots of x minus 4 of them, minus 3 lots of x plus 2 of them. It's the same as this stage here when we said there's 20 minus 33. That's the minus 13 that we appear in the top. But there's this number of 50/5ths minus this number of 50/5ths. In this case, 4 lots of x minus 4 of these minus 3 lots of x plus 2 lots of these. So the top line needs a bit of simplifying. So 4 lots of x minus 4, we multiply both of these terms by 4. So we get 4 lots of x minus 4 lots of 4, 16. And then outside this bracket, we've got a minus 3. So minus 3 times the x, and then minus 3 times the positive 2 gives you negative 6. So still a bit more sorting to do. 4x minus 3x is 1x, minus 16, and another lot minus 6 is minus 22. If you're not sure of that, think of a number line where you're going to minus 16 and then another minus 6. So we'd get to minus 22. So it's x minus 22 over x plus 2 times x minus 4. Now that's in its simplest form. There is no more cancelling that can go on. We can't cancel any of these factors. X plus 2 is one factor, x minus 4 is another factor. The only way we'd be able to do cancelling is if we ended up with with an answer that looked similar to this, where, gosh, there's an x plus 2 factor in top and bottom. We can divide top and bottom of this fraction by x plus 2 and we'd be left with 3 over x minus 4. That's not the case here. That's the final answer.